Okay, I'm on to question 4. Sam has another thought. He realized that if he places the pen in the corner, so I've got an original, an existing fence there, and he's just going to use that 48 meters, sorry, not centimeters, of fencing to make these 3. Now, I'm just going to make them all the same size. Diagram not to scale, special conditions apply. So, calculate the dimensions of the total enclosure, which result in a maximum total area. So he's got 48. So if he makes this x, he's going to need x there, and x there. And then this length over here would be 48 meters minus these 3. They would all need to be the same. So the area of each of these is base times the perpendicular height, which is 48 minus 3x, and that height there is x. So this will give me 48x minus 3x squared, and so that's my area. It's my area that I'm wanting to maximize. So dA dx is equal to 48 minus 6x, and we are maximizing it, so we're going to let that equal 0. So I get 6x equals 48, and therefore x equals 8. Okay, so I haven't finished because that's just telling me that that's 8 over there. So my actual dimensions are 8 meters by 48 minus 3 times 8. So 48 minus 24 is 24, so 8 by 4 meters squared, and that gives me, sorry, by 24 meters squared, this gives me 24, and that gives me an area of 192 meters squared. So I guess the thing is coming up with the this, what we're actually looking at. So the diagram is really, really helpful. That's a 24. Okay. Thanks for watching.